All right, so today we're going to focus on the last form of graphing. This is called vertex form. A is still present in this form, which shows whether the parabola is upward or downward and how wide or narrow it is. The thing about vertex form is it's very easy to tell where the vertex is because it's just going to be an h comma k right here if you have it in vertex form already. And so the directions for vertex form are as follows. We're going to find the vertex coordinates using vertex form. So I'm just going to rewrite it here. Y equals a times x minus h squared plus k. That was vertex form. H comma k is the vertex. So h would be 3, k would be -8. So that's our vertex. So we spent all that time finding the vertex before. We had to find the number halfway in between the x-intercepts, or we had to do x equals -b over 2a before. If you have vertex form, you just have to plug it off this form. So notice the number next to the x, we take the opposite of that number, and that's the x value of the vertex. And then the y value is just that number. So it's the opposite right here, and then the k is just the k. So that's the vertex, and so I'm going to go ahead and graph that. 3 comma -8. And I can go ahead and throw that on my graph right here. 3, -8. So that's the best part about vertex form, is finding the vertex is very straightforward. Again, the x value of the vertex is just the opposite of the number by the x. The y value is the number outside of the parentheses. We're going to use the a value to find 2 additional points. So a is the number outside of the parentheses. So for this, a is 2. So here's our a value of 2. So from my vertex, I can go up 2 and right 1 and left 1. So from my vertex, I went up 1, 2, and then left, right 1. Then I'll plot my y-intercept. This is the most math that is involved. So we know our y-intercept occurs when x equals 0. That is always true. But we don't want to be confused and think that that occurs at -8, because we're not in standard form. We're in vertex form. So we have to actually plug in x equals 0 into our equation and solve for y. So I'll do that. Y equals 2 times 0 minus 3 quantity squared minus 8. That's kind of stuck there. So I'll go over here. It's 2 times -3 squared minus 8. Because 0 minus 3 is just -3. And then if I do this math, we know -3 squared is 9. 9 times 2 is 18. 18 minus 8 is 10. So that means my y-intercept is positive 10. Or you can just type all that into your calculator, whatever floats your boat. So I'm going to graph the 10. So after I have found that, I can use symmetry to find another point. Now, personally, I have a little difficulty doing this without drawing my line of symmetry. So the line of symmetry is the line that goes through my vertex. On my graph, it's that black dot. So here it is. And then I can see my y-intercept is 3 to the left of it, 3 to the right, 1, 2, 3. I can plot another point there because I always have that symmetry because the parabola is such a symmetric graph. And then I can draw it. questions on that? So vertex form works very well if you have an equation already in vertex form. But if you can look down the page, that next equation isn't in vertex form, and this is where it takes some algebra to get it there. So to get this equation in vertex form, we are going to need to complete the square. So what I have to do is take out the 1/2 x, or sorry, the 1/2. I'm going to leave this 2 on the outside, so the +2. This is going to be a little tricky, and I know it's close to the end of the day, so you're going to have to bear with me here. So I put the 2 on the outside, so kind of keep this 2 on the outside. The 1/2, here's the x squared, because we know 1/2 times x squared is 1/2 x squared. But I have to think about, here's my y equals, what 1/2 times what would equal 1x? That's the only term I haven't accounted for in this. Will? 2? Is it just 2? 2x, yeah. That's a 2x. So currently, I have what I started with if I were to distribute the 1/2. 1/2 times x squared is a 1/2 x squared. 1/2 times 2x is 1x. And then over here I have the 2. Is this vertex form? It is not. So what I need to do is complete the square. So what I'm going to do is add a number on the inside of this parentheses that will complete the square. And this is a skill we had to do when we were solving quadratics, so it kind of ties it together nicely. So remember, to complete the square, I had to have this number and then square it. So when I halved it, I would get 1.
It's 1.
Yep, square it, and I get 1 again. So I have it and square it. Now if you add a 1, you have to counteract adding something else or subtracting something else. You can't just add a 1 and expect the equation not to change. Now, did I actually add 1? What did I actually add? I added a 1/2 because I added 1 times a 1/2. I added a 1/2 because of the 1/2 on the outside. I added a 1/2, so to counteract it, I'm going to subtract a 1/2. Or I could add a 1/2 to the other side. It's really up to me. But since I want to all stay on one side of the equation, I added a 1/2, so I subtract a 1/2 because I'm just trying to stay on one side. So since I want to stay on one side, I added a 1/2, subtracted a 1/2. And again, it's 1/2 because of the 1/2 on the outside. So when I go to rewrite, it is 1/2 times x plus 1 squared plus 1 and 1/2. So this part is the factorization of x squared plus 2x plus 1, and then all I did is subtract 2 from a 1/2, and I got 1 and 1/2. Now, is that vertex form? Does that look like it? I'll write it here. It's y equals a times x minus h squared plus k. Does that look like it? Okay. So what is the vertex? Yep.
It's 1 and 3/2. Yeah.
You're close.
Oh, would it be -1?
Mm-hmm. So it's the opposite of the number by x, comma the y. So it's -1, 1 and 1/2. So I'll go ahead and graph that. -1, 1 and 1/2. What is the A for this? Correct? Yep. So from that point, I'm going to go up 1/2, left 1, right 1. Remember, we're not going up 1 over 2. This is not lines. We go up 1/2. Yeah, then it says plot the y-intercept. Well, I actually already know my y-intercept because I ran into it doing my up 1/2, left, right 1. So if I want to know another point, which is generally always useful, I can just pick a value, like pick x equals, I like to pick even numbers because like you have halves here. Or actually, maybe I'll pick 3. 1, 2, 3, x equals 3. So instead of plotting the y-intercept, pick a value for x and plug it in. And you can plug it into the original equation. You can plug it into the vertex form of the equation. It's really up to you. So if I plug that in, I'll just do the original one. Y equals 1/2 times 3 plus 1 squared plus 1 and 1/2, if I want to do the vertex form. So this is 4 squared, that's 16, times 1/2, that's 8, 9.5. So that's a point that the parabola travels through. 3, 9.5. 1, 2, 3, 1, 2, 3, 4, 5. So here's 9.5. So again, if the y-intercept isn't helpful, you can just pick another point. It's up to you. And again, if you have a scientific calculator or a graphing calculator, you can type that in all at once. And then using symmetry, I can draw my little line. And this is 1, 2, 3, 4 to the left, 1, 2, 3, 4 to the left. I get another point, and then I can draw. So again, that other point doesn't have to be the y-intercept. It's just easy to find because you get to deal with 0. Questions on that? Okay, let's do the last one. So this one is not in vertex form, so we're going to get it there. So first step, we factored out the 4. X squared plus, and then the plus 2 went on the outside. What would the x term be on the inside? Myself a little more room here.
Since you have 3x underneath.
Okay.
Divide by 2, so it's 3 over 2. Square the whole thing. 9 over 4.
Okay. 9/4. And then what did we actually add? So we halved it and then we squared it. Halved it, squared it, but what did I actually add here? 9. Yep. 4 times 9/4 is 9. So if I add 9, I subtract 9 to counteract. Please let me know if there are questions on that. Because if I add 9/4, but I added 9/4 within the parentheses. You guys stay with me, please. It's the last one. I added 9/4. What's 9/4 times 4? The 4's cancel. That's 9. So you add 9, you subtract 9. Okay, so let's write this in vertex form. So I'm going to factor. Now the beautiful thing about factoring that part in the parentheses is we already know the factorization is right there. So it's x plus 3/2 squared, and then minus 7 I get from the 2 minus 9. Okay, who would like to tell me what the vertex is, the coordinates? Zoe?
Negative 1.5 and 0.25. Or is it 7?
Negative 7. Yeah, so 3/2 is that 1.5 right here. She just took the opposite of that number, and then negative 7. Right?
You can move the fraction form.
It's totally up to you. So just write that. The 1.5 came from here. Negative 1.5 is the opposite of the number by the x, comma, the 1. So let's graph that. So we're down below. Negative 1, 2, 3, 4, 5, 6, 7. Right there. A is 4. It's going to be a very skinny one. Okay, so from there I'm going to go up 4. 1, 2, 3, 4. Left to right, 1. Now, if you are given the y-intercept, or if you're given it in standard form, the y-intercept is very easy to find. The y-intercept occurs when x is 0. So you can just look at the original one. If you plug in 0 for x, what's y going to be? 2? Good. All the way up there. Ooh. And then I can draw in my line of symmetry. Oh my gosh, that line is way too thick. Let me redo. There we go. And I can do the symmetrical point. Is that right? No. There we go. It's so skinny. It's a little pretty one. All right. It's like the Charlie Brown Christmas tree. All right, so I think the most challenging part is getting it in vertex form. So if you need help with that, ask me. Help with anything, ask me.